Okay, hello math analysis. This is the answer key to page 21, so we're going to do this together right now. All right, so first off, if you look at this, they want us to use the Hamilton method, and step number one is to always find the ideal ratio, and so I need to add up all the numbers in the population. So I have 315 plus 274 plus 215 plus 184 plus 140. So I have a total population of 1128. So I'm going to put that down up here. Oh, they told me that. Hey, hey, hey. And they're giving away 18 seats, so we divide that by 18, and that gives me an ideal ratio of 62.666 repeating. So we're going to use 62.67 for our ideal ratio. Now, if you remember what I showed you yesterday, let's store that in our calculator. So I'm going to press store, and then I'm going to press X right there. And then if I just press enter, you see what happens is that it stores that value in X. So now when I have to find the quota and divide by the ideal ratio, all I'll do is hit divided by X. All right, so I'll just show you that it works. So they take 315 divided by X, and their quota is 5.02, and it rounds up to 5.03. So you can see that we got the right quota on that one right there. Okay, so they figured out all the quotas for us. So the next step is calculating the initial apportionment. So remember with Hamilton, he truncates the decimal, so he cuts them all off, and that leaves him with 5, 4, 3, 2, and 2. So our next step is we have to total this up. So 5 plus 4 is 9, plus 3 is 12, 14, 16. And remember, we're trying to give away 18 seats. So we still have to add 2 more seats. So remember the way that Hamilton does it is he looks at the decimals and he gives it to the largest truncated decimal. So Hamilton is going to like this guy first. So he'll be the first one that gets the extra seat. And then our next biggest one looks like this guy right here. So he'll be the second one to get the extra seat. So when I assign those extra seats, the first one that got it was right here. That'll go to 3. And then this one will go up 1 to 4. And everybody else will stay the same. And when I total that up, I have 5 plus 8 is 13. And 13 and 5 is 18. And the process is over. All right, now let's take a look at the Jefferson method. So with the Jefferson method, remember, he starts off the same way as Hamilton does, and he just truncates all of the quotas decimals. So he gives away 5, 4, 3, 2, and 2. We add that up, that's 9, 12, 14, 16. So he also needs to add 2. But remember, his method is a little bit harder than what Hamilton does. He takes the class size and he divides it by the initial apportionment plus 1. So let's go through and do some of those together. All right, so you should take out your calculator, make sure you know how to do this. So here we go. So for the first one, the class size is 315, and he's going to divide it by, he initially gave 5, so I'll divide it by 6. And they get 52.5 for their adjusted ratio. So I'm going to say put the video on pause and go ahead and calculate the rest of those and see how you do. So I'm going to move this paper up a little bit so you can see that. So I'm going to fill in the rest of the adjusted ratios and see if you get the same. Here we go. So I'm going to take 274 and divide that by X. I lied. I'm going to take 274 and divide it by 1 more than they got before, which is 5. All right, there we go, 54.8. Okay, then I'm going to take the 215 and divide that by 1 more than they got before, so we'll divide by 4, which is 53.75. Okay, then I'm going to take the 184 and divide by 1 more than they got before, which is 3, so 61.33. And then I'm going to take the 140 and divide by 1 more than they got before, so 3, and that's 46.67. So remember what we do. We are trying to find the ideal ratio, which everybody was the same size at 62.67. So whoever it's closest to is the group that we're going to give the first extra seat to. So you could see in this instance that the 61.33 is closest to 62.67. So they'll be the first group that I give the extra seat to. And then the next closest is this 54.8. So that'll be the second group. So instead of 4, I'll give them 5. Everybody else stays the same. And when I total this up, 10 plus 6 plus 2 is 18. And I completed the process with the Jefferson method. All right, so that was the Jefferson method. So now let's take a look at the Webster method. So this will be our final method. Now the Webster finds the ideal ratio the same way. He adds up all the people and divides by the number of objects, so it's still 62.67. And he gets his quotas the same way, which is the class size divided by the ideal ratio. But what he does to the quotas to get the initial apportionment is a little bit different. Remember I said Webster, as in webs, and spider webs are round. So he rounds. So we look at these digits here. 3 is less than 50, so we'll round down and keep 5. 37 is less than 50, we'll round down and keep 4. 43 is less than 50, we'll round down and keep 3. 93 is greater than 50, so I'll round up and keep 3. And 23 is less than 50, so I'll round down and keep 2. So when I add this up now, I have 9 plus 12. 12 and 3 is 15, plus 2 is 17. So we still have to add one more. But now we have to calculate the Webster adjusted ratio, which remember he does the class size divided by the initial apportionment. Now because we have to add one more seat, we're going to say plus 1/2. So here we go. I'm going to calculate all of those. I'll show you how those are done. So for the first one, we take the class size, which is 315, and I'm going to divide it by, initially we gave 5, so I'm going to divide it by 5.5. And I get a Webster adjusted ratio of 57.27. Okay, let's do the next one. We have to take the class size of 274, and initially I gave 4, so I'm going to divide it by 4.5, and I get a Webster adjusted ratio of 60.88. Okay, let me do the next 3 down here. I'm going to take 215, and I'm going to divide that by 3.5, and that gives me 61.4. And I'm going to take 184, and I'm going to divide that by 3.5, and that gives me 52.57. And finally, I'm going to take 140 and divide that by 2.5, and that gives me 56. Even. All right, so now I'm looking for the one that's closest to the ideal ratio. The ideal ratio is 62.67.